Hi, welcome to Chapter 2, starting out with Python. In this chapter, we're going to talk about designing a program. We're going to talk about the input, processing, and output. We're going to display output with the print function. We're going to talk about comments and variables. We're going to, in that process of inputting, we're going to read input from the keyboard. And as part of the processing part, we're going to perform calculations and string concatenations. And then finally, we're going to talk about an output, how to use the print function, as well as using the print function to display formatted output. We'll talk briefly about named constants. However, in this class, we don't go over the turtle graphics piece, so you can ignore the turtle graphics portion of this chapter. So let's start with talking about designing a program. When we as developers start to write a program, we should use what's known as the 80-20 rule. 80% of our time should be used to design, and 20% is coding. The reason being is if we develop a really good design and we take the extra time to really think through the design and create all the required documents that we would want to create when doing a design, then when we go to code, most of the work's done for us and we're just actually developing the code of something we've already designed. Many of our challenges will have already been thought through, and we just won't have as many syntactical errors if we do a really good design. So when it comes to the development cycle, our first step is to design the program. After we have a really good design, then we write the code. Once we have the code written, we want to run the code, and in that process, the system is going to tell us all of the syntax errors, and we'll need to fix those. Now that the program can run, we'll run it and we'll test it. With that, we'll find logic errors, and so we'll correct those logic errors. And typically, from here, we'll go up and test the program. Now, sometimes in the development cycle, we do this phase and we develop pieces of the code, in which case, if that's what we're doing, then once we get a piece of the code through all 5 of these steps, then we will come back, and usually we like to design the program from beginning to end, but if we needed to design the next phase, we would go back to step 1 and design the next phase. If the next phase has already been designed, then we would just go right to write the code, and we would go through all of the steps again, keep repeating as needed. As we've already discussed, design is definitely the most important part of the program development cycle. We want to understand the task that the program is to perform. To do this, we want to talk to the customer and really ask them, what's this program supposed to do? Ask a lot of questions up front and kind of run through the program in your head as you're talking to the customer. This will allow you to figure out more questions to ask. When we walk away from talking to the customer, we want to make sure that we have this list, often known as software requirements. Software requirements is that list of minimum tasks that need to be completed to accomplish our program. And in that, we want to determine those steps that must be taken to perform the task. Now, break down those required tasks into a series of steps. Here in a moment, we'll talk a little bit about flowcharts, and that's one way we can do that. We want to create an algorithm, which is listing logical steps that must be taken. Whenever you have a well-defined logical steps that are done in order to perform a task, that's known as an algorithm. Pseudocode is really important, and take a moment to understand what pseudocode is. Pseudocode is just fake code, but it's the idea behind pseudocode is it allows you to essentially kind of write a program and whatever words make sense to you. They don't have to follow any kind of syntax rules. It's never going to be compiled or executed. In fact, what we're doing is we're creating a model program. We're, we're in a sense, we're kind of whiteboarding out our program. So we don't need to worry about the syntax errors, and we can instead focus on the program's design. How do we want this program to work? And we can use our own simple words to describe how we want the program to work. When we do this, we'll have essentially a list of code comments. And we'll talk about code comments here in a moment. But from there, we can then go back and fill in real code into our pseudocode. The other nice thing about pseudocode is we don't have to really care what the actual programming language is going to be. So maybe we don't know ahead of time what our programming language is going to be. Maybe we want to do pseudocode to help us figure out what the best programming language is. Nonetheless, we can still do pseudocode because it doesn't care about any of that. It literally is just your own words, kind of like spitballing out the steps you think need to be accomplished to get your program to work. So let's talk a little bit about flowcharts. A flowchart is a diagram that graphically depicts the steps in a program. So for example, ovals are used as terminal symbols. So here's our nice little oval. Parallelograms are input and output symbols. Rectangles are processing symbols. And symbols are connected by arrows that represent the flow of the program. So here, start and end are ovals. So that is, as we just described, our terminal symbols. Here's our parallelograms. And those are input and output symbols. So here we have input the hours worked and input the hourly pay rate, and then display the gross pay. So this is input, this is input, and this is output. Rectangles are processing symbols. So here is our code. This is how we're processing. And if you remember back when we first started talking, when we were going over the things we were going to cover, here's your input, here's your processing, and here's your output. By the way, what's nice about flowcharts is, again, they are somewhat program agnostic. We don't care what language we're going to write these in. And in fact, when we're looking at this documentation later, it doesn't matter what the program language was used or what was picked to actually write the code. I don't even have to be an expert in that language to read this and understand what the program's trying to do. So now we got that input, processing, and output. So typically, computers perform 3 steps when it comes to processing. We receive input, and input's important because if we were writing a program that we ought to always use the same data as like our starting point, then the program would never be different. It would always run essentially the same thing over and over again. So that's why oftentimes we receive input. Sometimes input comes in from the user. Sometimes the input is from maybe data that we're pulling. Once we have that input, now we're going to perform some processing on the input. We're going to massage it and manipulate it and do something to that input And then typically we then produce output. Sometimes output is to the screen, sometimes it's to maybe a database, or maybe we output to a file. Nonetheless, we're going to have some sort of output. When we come back, we're going to jump into the print function, and that is how we display output. So when we come back, that print function will be the first thing we talk about, and we'll also talk a little bit about how we can use the print function to format data to the screen.